All right, today we are going to be converting from radical form and back to rational exponent form. This is our last lesson with our radicals before we take our test. And it's kind of one of my favorite because you get to sing a song. Okay, everybody remembers the song Old MacDonald, right? You say, Old MacDonald had a farm, E-I-E-I-O. All right, so we have to remember the E-I part. So here we go. We're going to see a radical, and we're going to convert it back into an exponent, and then we can go back forth. So let's say right here, this is our index, and this is our exponent. Everybody good with that? Remember, index is the small and that crook of that radical symbol. And this could be, x could be any letter, the whatever power. So to go back into this, we have to remember our song of Old MacDonald. It's E-I. So E, the exponent goes in the numerator, and then I in the denominator. This helps us if we want to simplify expressions, mainly when they look like this. We want to enable to solve them really quickly. We can convert them back into rational form, or a radical form, and solve that. So here we go. Let's do some sample problems. All right, so take it some time. We're going to write 9 and 2/3. 9 to the 2/3 power. So this isn't really a great problem to solve. It's kind of hard to do a fraction with your exponent off the top of your head. So we're going to convert this into a radical form. So we're going to have, remember, 9 is always going to be our radicand. Whatever your base is, your exponent is your radicand. And then, remember, it's EI. So 2 is going to be my exponent, and my index is going to be 3. So what I know, and then I can evaluate that. 9 squared is 81, so square root 3. So now I'm going to prime factor out 81. So you don't have to prime factor for everything right here. So we know we have 3, and then that's 27, 3, 9, 3, 3, 3. And to simplify that, we have our group of 3. So we know it's 3 cube root of 3 is what it simplifies down to. Okay, so for right now, today's purposes, we're just going to be getting to the 3. We're just going to be getting to this part. Okay? All right, so next time we're going to have 9. Remember, EI, so it's going to be 9 to the 4th, and that's going to be to the cube root. And we can evaluate that as 9 to the 4th is 6,561. And we know that we can go about and we can simplify that if we normally know how to. All right, so y to the 5th, the 5/7. So remember our exponent is going to be y to the 5th, and this is going to be to the 7th root. And since we don't know what y is, we can't simplify it. All right, well, we could simplify it if we wanted to. We can take, there's not 7 groups of 5, so that's a simplified as it goes. All right, next up, y to the 4th, oops, I wrote this wrong. Should be more of a fraction, not a, so this is going to be y to the 4th, square root 11. It'd be 11 root of y to the 4th. All right, now we can go backwards. So remember we said EI, so y is going to be my base. My exponent is 9, so that's the numerator, and 5 is the denominator. Over here, EI, so remember y, my radicand, my base, 7 to the 8th. And we're going to have x to the 7th to the 4th. Then we could go back and we could combine like terms if needed. I could add these exponents together to combine them, because normally we weren't able to combine using our adding and subtracting rules because I have different radicands, because we're to the 9th and the 7th, and different indexes. But now, since they're the same base, we can go about adding them. This is a very important skill for Algebra 2. In Algebra 1, all we're really doing is practicing going from the radical form to the rational form and vice versa. Okay, one more thing we're going to work on is our applications with our radicals. Okay, so no little word problems. So much fun. All right, the biggest thing is you have to remember perimeter and area and what that means. All right, so here we go. Kevin has built a fence around his pool. Now he wants to know how much area he will have to put out some chairs and tables. Kevin measures the fence in area at square root 8 by square root of 9 feet, and his pool measures 3 by the square root of 6. What is the total area of the walkway around the pool? I'm going to draw a little picture to help us. So here's our pool. He wants to know all this space right here. So he knows that the fencing area is going to be square root of 8 times the square root of 9. If you want, you can simplify your radicands. You don't really need to because you're going to end up simplifying later. And then we know his pool is going to be square root of 3 by the square root of 6. So I want to figure out, I want to be able to take out the pool and know how much area I have left in. So to do that, we have to find the total area. And remember, finding area of a rectangle is length times width. So this is going to be square root of 72. And 3 times the square root of 6, which is going to be the square root of 18. And I want to figure out what I can take out. So we're going to do square root of 72 minus the square root of 18. And remember, now we're adding and subtracting radicals. We need like radicands and like indexes. So I'm going to simplify, and I'm going to get 6 square root 2 minus 3 square root 2. And then we're going to subtract. So we're going to have 3 square root of 2 feet is going to be his area. He can put chairs and all that fun stuff out. All right, now the next part. A regular octagon side measures length of 2 square root 6 inches. What is the perimeter of this octagon? Perimeter means the distance around the shape. Remember, an octagon looks like your stop sign. How many sides does an octagon have? That's right, 8. So we're just going to multiply 2 square root 6 times 8. And then we're going to go 8 times 2 is 16. Square root 6. And can I simplify square root of 6? I can't. So we know it's just going to be inches. And that's our final answer. All right, I will see you tomorrow.